Welcome back, geographers. Here we are for another edition of Human Geography Information with more flowers from Mr. Jerry, my neighbor. Some of them here are dying, but some. I mean, look how this is like the size of my face. So there's more about maps, right? We're still going to learn about more about maps. We're saving all this foundational information in the first unit so we can do cooler things throughout the year. I'm losing daylight. It's starting to get chilly, but we're ready to do this. All right. So when we think of maps, we learned about is it a reference map or, a thematic map and all those things. But keep in mind that a map is a projection. It's a projection of the Earth, right? So it's taking the spherical shape of the Earth and what's on the Earth and trying to display it on a flat surface, right? And you see that's not really easy to do because if you have a globe, right, you could not flatten this out completely, right? And if you do, it would be distorted, right? This NCAA would not look just like this if you flatten this out. So how cartographers decide what to distort and what not to distort is what makes up the different types of projections. I missed. It was like a few feet short though. All right, maybe later. I did not go to college for basketball. All right, so let's learn about some of these projections. Now, projections are either conformal projections or equal area projections. So an example of a conformal projection would be the Mercator projection, right? If you were in class, we did an example, a multiple choice example of a Mercator, but I'll show you one again in a second. So what does a conformal map get right? It gets right the shape of the land features. It preserves those shapes and those features, but it distorts the true size, right? So whenever you have something correct, it's going to come at the expense of something else. So on the right, you'll see there's an example of an equal area projection. So this usually distorts the oceans, but it preserves the size of the landmass, right? So it's always right, a give and take. Now, there we go. So the Mercator projection, let's come back to this. That is the Mercator projection above it. And notice it looks pretty accurate in the middle, right? But it looks like the bottoms are stretched out. So it has the latitude and longitude right. It has the shape right? The shape of the land masses is right. But it distorts the size at higher latitudes. Notice Greenland is nowhere near it has it here as bigger than North America, is bigger than Africa. That's really not the case if you were to look at a globe, right? So Mercator projection, it's good for navigation because not too many ships navigate up in those other areas. Mostly are towards the center. So for navigation, Mercator projection would make sense. Now, what about the Gall-Peters projection? Now, look, what is stretched here? What is distorted for the expense of something else? Here, the size is actually fairly accurate, but the shape is not, right? The shape is not accurate. This is the opposite image of the Mercator. So if you see the Mercator sort of stretched at the ends, you see it's the opposite here. One or the other. What are you going to use and why? Here's the Robinson projection. You see this one a lot. Lots of atlases will have the Robinson projection. The size is correct. The shape is correct, or not 100% correct when I say correct, right? But it's fairly accurate. But the polar areas are once again distorted. So, that's where that's compensated. We also have the goods projection. You see this from time to time as well. So once again, the size is about accurate. The shape is pretty accurate, but it's weird looking, right? It's because you're missing a lot of the ocean. It's to make it flat, here we cut out these areas, right? But how many people use maps for oceans, right? Usually people use world maps to look at the landmass. I'm not dissing people that study the ocean, but that's just how it is. And Gal Peters projection. Oh, we already did that one. So we're going to continue with our next video with geographic data and how do we collect it. We'll give you a break here, and we'll print out some examples of the different maps so you have them in your notes, but it doesn't hurt to go maybe look at a textbook and see the examples on your own as well. All right, stay tuned for part 2.